Hello everyone, I hope you're doing well and taking care of one another. I know it must be really weird to try and learn new things at home, but even at home you can do science. There's science everywhere. So today we're going to be doing a few experiments and we're going to be learning about molecules and chemical reaction. Have you guys ever heard of the word molecule before? Well, a molecule is something that is made up of atoms. Everything around us is made up of atoms and molecules. The air we breathe is made up of nitrogen molecules and oxygen molecules. The water I'm drinking right here is made up of water molecules. If you use a very, very powerful microscope and zoom in into this water, you'll see that each molecule of water actually looks something like this, where there are two hydrogen atoms and an oxygen atom making up a water molecule. The cool thing about these molecules is they can react with one another and combine and change form and make some new things. So, I have a quick question for you. If we freeze this water, if I put this water into this ice tray right here and then put it in my freezer, what do you think is going to happen? Do you think that's going to be a chemical reaction? Do you think the atoms and molecules in this ice tray are going to change? Probably not, right? An ice cube is still made up of water. It's the same thing, it's just in a different form. However, if you put electricity into this water, for example, that can cause a chemical reaction. What ends up happening is if you have two water molecules, this water has billions and billions of water molecules, obviously. But if you just have two water molecules and you give it energy through electricity, for example, they will actually recombine and form something pretty cool. They will form two molecules of hydrogen, which is just these guys right here. And form one molecule of oxygen. And this is how a chemical reaction happens. Atoms in a certain material can change form and form different molecules. That's a chemical reaction. If you just have something that is boiling or freezing, you're not having a chemical reaction. You're just changing its form by making it really cold or really hot. So, how about this? Do you think when you're baking or when you're cooking and you accidentally burn something, is that a chemical reaction? Well, it is. For example, right now this paper is made up of a whole bunch of molecules that consist of different fibers, right? But if I light it on fire, what ends up happening is this paper turns into ash and gas, which is carbon dioxide. So this is what we're going to be doing today. We're going to be exploring the world of atoms, molecules, and chemical reactions. We have some experiments for you today, and you can follow along at home. You can do these experiments at home as well. However, make sure that you have a parent or someone older than you keeping an eye on you. Some of these experiments could be dangerous, and we want to make sure that you don't accidentally hurt yourself. In this first experiment, we're going to be making elephant toothpaste. Elephant toothpaste is pretty cool. In this chemical reaction, we're going to be using something called hydrogen peroxide. You may have heard of this. Hydrogen peroxide is often used to treat wounds. And hydrogen peroxide, if you zoom in really, really close using a really, really powerful microscope, you'll see hydrogen peroxide is made up of molecules of H2O2, where you have two hydrogen molecules, or atoms, here, and two oxygen atoms, here and here, to make your hydrogen peroxide molecule. In this chemical reaction, what you'll be doing is you'll be breaking down this molecule to form a gas. You'll be forming oxygen gas and hydrogen gas. So what happens is you have this molecule and we'll be breaking it down using a catalyst, and it will be forming an oxygen atom and a hydrogen atom. The catalyst we're going to be using for this chemical reaction is going to be yeast. This is just regular baker's yeast that you might find in the baking section of your grocery store. What a catalyst does is it essentially just speeds up any chemical reaction. So that's what the purpose of the yeast is going to be. It's not actually part of the chemical reaction, but it will help it speed up. All right, so first we're gonna start with about half a cup of hydrogen peroxide. We're gonna be measuring it out using this measuring cup we have here. All right, that is about half a cup. And we're gonna be pouring this half of cup into a bottle. So here we just have a bottle, an empty soda bottle that I've washed out. And we're gonna be pouring the hydrogen peroxide solution, which is made of those hydrogen peroxide molecules like I showed you earlier, into this solution. Into this bottle right here. All right, so we have our hydrogen peroxide in our bottle. To make this nice and fun, we're gonna add a squirt of dish soap into this. So we have some regular dish soap, and the dish soap is gonna help make this nice and foamy to make our elephant toothpaste. That's a nice squirt, that should be good enough. And to make it even more zesty, we're gonna be adding a little bit of food coloring. Try and make this look like actual toothpaste. I'm gonna have a few drops of yellow, a few drops of blue, and a few drops of red. So when this comes out, it's gonna look like actual toothpaste. All right, so you can see the food coloring. I just kind of put it on the side of the bottle so it kind of slides down the side. And now next we need warm water. This is 3 tablespoons of warm water that I just microwave for about 20 seconds. And then we're gonna be adding the yeast to this warm water. The reason we do this is because we want to activate the yeast before we add it to the hydrogen peroxide. This is going to help make the catalyst work a little bit faster. So yeast is an active organism. You use it in your bread, and it's what helps the bread rise. It makes those little bubbles in the bread. So essentially what we're doing here is we're also making bubbles, but we're going to be making these bubbles super quickly. So I'm just mixing this yeast up, mix it for about 30 seconds until you get a smooth slurry. And at this point you might be noticing, hey, this chemistry thing I'm doing right now is a lot like cooking. That's true. Chemistry is a lot like cooking. So if you like to cook, you might like chemistry. Something to think about. Okay, so once I get a nice smooth slurry, I'm going to get ready to put it into our bottle of hydrogen peroxide and start this chemical reaction. I'm going to put this bottle on a tray here just to make sure I don't make a huge mess. But let's see what happens, shall we? All right, just going to pour it in. And here it goes. As you can see, the hydrogen peroxide is decomposing and breaking up, forming gas, hydrogen gas and oxygen gas. As it breaks up, it is forming bubbles, and that is making this elephant toothpaste. So it looks like the bubbles have stopped forming. I'm going to add a little bit more hydrogen peroxide in here to see if that helps. Yeah, here it goes. And as it comes out, you'll notice that this is actually getting pretty warm. This is because this is an exothermic chemical reaction. In this chemical reaction, what's happening is as these bonds break and the atoms rearrange to form these new molecules, we're releasing energy in the form of heat. And this heat is essentially the energy that's being released when these bonds break. And that's why this bottle is getting warm. And as you can see, we're forming our elephant toothpaste. Obviously, you want to make sure that you don't actually use this for toothpaste. This is not real toothpaste. But it kind of looks like toothpaste, right? With the food coloring and the foam coming out. You can get nice, foamy, toothpaste-like suds coming out of your bottle. And this is all due to a chemical reaction, as I said, with this liquid hydrogen peroxide forming gas and making these bubbles. So that was a pretty cool experiment, right? In that last experiment, we took hydrogen peroxide, which is H2O2, a liquid, and decomposed it into H2, which is hydrogen gas, and O2, which is oxygen gas. Because gases take up more space than liquids, it created bubbles. And these bubbles expanded with the soap and created our elephant toothpaste. In this next experiment, we're going to be doing something similar. We're going to be looking at sugar. As you guys probably know from experience, sugar has a lot of energy. If you eat too much of it, you might start feeling hyper. So our body actually uses sugar to create energy. This is what a sugar molecule looks like. It's actually pretty big. It is C12O11H22. So that means there are 12 carbons, 11 oxygens, and 22 hydrogen atoms in this molecule of sugar. Just like hydrogen peroxide, these sugar molecules can decompose to release energy, and it will decompose into carbon and carbon dioxide. So that's what we're going to be doing today. We're going to be decomposing sugar. We're going to be starting with a little bit of powdered sugar. This can be found at the grocery store. We're going to be using baking soda, and the baking soda is going to be used just as a way to create more gas. And you'll see that when we create these fire snakes, which is this chemical reaction we're going to be doing today, we will be seeing the sugar decompose into carbon and carbon dioxide, and the baking soda will help create bubbles inside this chemical reaction to create essentially what is elephant toothpaste, but with carbon instead of with soap. In addition to that, we'll be using a little bit of isopropyl alcohol. This is going to be used to ignite our reaction. This is going to be a highly exothermic reaction, meaning that this will be giving off a lot of energy. Because of that, there is a lot of danger involved here, so make sure you take your proper safety precautions. Please, please, please do not do this by yourself. Make sure you have an adult with you when you're doing this. Also, it's a good idea to do this outside because this may produce quite a bit of smoke. And you want to make sure everything you use for this experiment is non-flammable. So don't use plastics, glass, and tin foil type baking plates like we have here should be fine. And then last, we'll be using sand. So this is regular sand that you can find at the playground, or you can find it at like a plant store, a hardware store. And this is going to be like the base for our chemical reaction. So the first thing I did is I got some of that sand and packed it down into a little plate. This is going to be where we're going to be putting our sugar. I'm going to be putting this plate into this tin foil pan here, and I'll be moving the camera a little bit later once I put everything in place. Okay, next I'm going to take 1 tablespoon of this baking soda and be putting it into the small bowl here. So yeah, 1 tablespoon of baking soda and 4 tablespoons of powdered sugar. All right, 4 tablespoons. Now I'm going to mix that nice and well. Make sure we have a uniform mixture of this baking soda and powdered sugar. Okay, that should be good. All right, now before we put the powdered sugar, we're going to be pouring IPA onto our plate of sand here. This is going to be acting as our fuel, and so it's important to have a good amount of fuel for our chemical reaction here. So just pouring a bit of this IPA. Make sure the sand gets nice and wet. Okay, that should be enough. So you can see that the sand is nice and wet. If you don't have isopropyl alcohol, this is just rubbing alcohol. If you don't have that, you can use charcoal lighter or barbecue lighter as well, fire starters. Once you have doused the sand in a little bit of IPA or some fire starter that looks something like this, I'm going to add a little bit of both in this case here. You can go ahead and put our mixture onto the sand. In this case, I'm going to only use a tablespoon of this mixture, because that should be plenty enough for everything that we will need or want. So here's a tablespoon of this mixture. I'm going to pat it down a little bit. Okay, so let's move the camera and see what this will look like. So here's our mixture. Right now, the sand is doused with IPA and a little bit of fire starter from fire starter, and then we put a mixture of baking soda and sugar onto the sand. The mixture is 1 part baking soda to 4 parts powdered sugar, and then we put about 1 tablespoon of that mixture onto the sand. Now we're going to be lighting this on fire. It's a good idea to use a lighter that looks like this so you don't accidentally burn yourself. You could use matches. Obviously, make sure you have an adult with you when you do this. You don't want to do this by yourself. I'm going to go ahead and light the sand on fire here. There we go. So you can see everything's on fire, and we should start seeing the sugar and baking soda solution reacting and forming carbon and carbon dioxide. Alright, so it took about 20 minutes until the flame went out, and then after that I waited for an additional 10 minutes to make sure everything was cool. So I'm going to go ahead and take this guy out. It's still a little warm to the touch, but you'll notice that we did see that this thing has grown significantly. It has like quadrupled, maybe increased in size by about 5 or 6 times. So the first thing I'm going to do is, it is still warm, but I'm going to try and pick it up. And you'll see that there's still a bit of unreacted sugar at the bottom, which is fine, which means that this guy could have grown a little bit more. But the very interesting thing about this is, even though this is so big, it is very, very light. And the reason for this is because this is mostly just air. So I'm going to break this in half right here. And I don't know if you can see this, but this guy is full of little pores, and I can just literally crumble it away and it's gone. So this is basically just pure carbon. Anything that's left in here is carbon. It's just soot. Same thing that you'll see in your fireplace after you burn a log, for example. It is very light. It is very powdery. It crumbles in your fingers very easily, and it's basically just pure carbon. What happened to the oxygen molecules in the sugar? Well, so the carbon molecules are all left here, right? The oxygen molecules became carbon dioxide, CO2, and was released into the atmosphere. So that's what happened. We have this giant molecule that we started out with, which is sugar, and it turned into just carbon, which is this black soot we have, and carbon dioxide, which just evaporated and went into the air. I hope you enjoyed today's lessons, and feel free to do these experiments at home, but make sure you have an adult supervising you. If you have any questions, you can let me know. You can leave a comment, or you can email me directly. And so we'll just go over what we've learned today. Today we talked about chemical reactions. Well, what is a chemical reaction? It is any type of reaction where the atoms in a molecule move around and change. This means that if you're looking at water that is freezing or boiling, that is not a chemical reaction, because ice is still made out of water molecules. Steam is still made out of water molecules. But if you break those water molecules apart into hydrogen and oxygen, then you can make that is considered a chemical reaction. Similarly, the experiments we did today, we looked at hydrogen peroxide, H2O2, and decompose that into hydrogen gas and oxygen gas to create elephant toothpaste. And that is one example of a chemical reaction, where the atoms are moving around and forming new molecules. In the second experiment, we looked at sugar, a larger molecule that has a lot of energy. And in this case, we decomposed this sugar into carbon dioxide, which is CO2, and ash, which is just pure carbon. In this case, both of these reactions were what are called exothermic, which means they release energy. That's why this became really hot and created a flame. And the elephant toothpaste was also warm to the touch if you decide to do that experiment. With that, thank you very much for your time, and I hope you guys have a beautiful week.